Hello, good evening. Last week you have finished 1.1 already, and I asked you to do some homework. Most of you are doing well, so from what I see lah, is doing quite well. Where? Basically it is okay lah. Not no, not a big problem here. Okay. You're doing quite well, so I mark for you already. Not only this, there is others. So I just show one only. Yeah, yeah. If they ask you what happened to the motion, so you better set accelerate downward. Alright, don't move downward only. Okay, accelerate downward. Others is okay. Here. So in diagram 6.1, the acceleration is 0, while in diagram 6.2, it's not. The acceleration is not equal to 0. What is mean by not equal to 0? So there is an acceleration, right? There is a constant acceleration. You have to tell me. But not equal to 0, it is correct. Also, but I want you to know how to use the word of constant acceleration. Type of the motion, the greater the resultant force, the greater the acceleration. Some of you answer me in other way, like which is not so good, which is some of you answering, some of you, like for example, I take your that one. Wait, let me find, I mark, then I find your that one. Not so good, but I still mark you correct. It is not wrong, but not so correct. Here, I show you. Right. The higher the acceleration, the higher the resultant force. So because of we got the result. Wait, the higher this one is correct. The higher the acceleration, the higher the resultant force. So from the diagram, the higher the resultant force. So we know that that is higher the acceleration. But actually both are correct. This one not so good lah, because of we see from the diagram, because of they got a very big resultant force. Then we know the acceleration is big. Okay, so I hope you understand what am I saying here. The more the resultant force, the more the acceleration. Okay, from the diagram. So the greater the forward thrust, the greater the resultant force. Others is okay. Forward thrust decrease. This one should be acceleration decrease. Other okay. Other is okay. So because of you are doing it well, so I don't spend long time into discuss this one. Right, this one is your homework. If you finish it, if you do it, then I will like mark for you. Right, you hand it up, then I'll mark for you. So today we are going to focus into 1.2. Okay, 1.2. This part, it is the most important one. Alright, 1.2, very, very important. If you know how to use it, then this chapter should be no problem already. So, now, very easy. The way that I use this here, if you want to do the resolution of force, so there is a force pulling here. So this force is actually, I can resolute it into two directions. One is x. So we call it fx. Right? This one I pull it to here, fx. Meaning that this one I also pull to here. This one is fy. Okay? Meaning that what, teacher? What force pull to here? I don't get it. Right? So it is terbalik from the previous one. Terbalik. What does it mean by terbalik? Like previous one is like I got 3 Newton here. I got a 4 Newton here. What is the resultant force? Right? For example, I got 3 Newton here. 4 Newton here. So this one, it is equal. You pull here 3, I pull here 4. So where will it go? It will come into this direction, right? 5 Newton. Right? This one 5 Newton. But now, it is the one that I give you here, 5 Newton. So it is equivalent to how much contribute to here. So we call it as Fy. And how much force it is contributing to the Fx. So we call this Fx. But why do I want to do so? If I do so, I can solve a lot of question easily. Okay, now come to the how to use it. Okay, now if you use my way, then my way is you touch, then you use cos. Not touching, then you use sine. All right, remember, you touch, then cos. Not touching, then sine. What is mean by touch? Okay, so here, F, I bring to here. You see, this theta, do you see this theta here? Right? I bring this F here, I touch this theta, I use cos. Touch theta, I use cos. If I bring to here, you see, I bring to here. Do I touch this theta? I bring this F to here. Do I touch this theta? No. No, then I use sine. Okay? But still sine this theta. Still sine this theta. Now, for example, right? I take one example here. For example, I got here. Now, this one, it is like 20 Newton. This is 30 degree. I use other color. Right? So, I got a F here. This 20, I bring to here. Now, this one, I'll call it as Fx. This one is Fx, huh? Fx is equals to 20 cos 30. 20, I repeat, 20 here, 20 here, I touch 30. 20, touch, I use cos. 20 cos 30. Alright? So how about if I bring to here, Fy. I want to find Fy here. Fy here, how do I find? This Fy 20, I bring to here. Touch this 30 or not? No, right? 20 sine 30. Okay? 20 sine 30. Because I am not touching this one, this angle is here. I don't touch the 30. I don't touch 30, but I still use 30. Now, of course, you'll tell me, Jaegu, how about this one is 90 degree, oh? Okay. This one is 90 degree. This one 30, mean this one is 60. Am I right? Yes. Alright. Yes. If yes, if so, then what do I do? Alright. So, now I press this number first. I press this number first. 20 cos 30, how much is this? I want to know. Right? 20 cos 30. It is 17.32. It is 17.32 Newton. Okay, how about 20 sine 30? 20 sine 30 should be 10. 10, yeah. Alright, so I'll get 10. 10 Newton. Okay, so I use other way. Like what I told you, I use other way. Now, see, this one is 60. This one is 60, yeah. So, 20, I bring to here. Touch 60 or not? I said 60. Touch 60 or not touching? No, right? So, it touched 30, not touching 60. Not touching 60. I want to find Fx. How much is Fx? Fx is 20. You bring to here, not touching 60. Not touching, I use sine. Sine 60. 20 sine 60. Right? So, 20 sine 60. 20 sine 60. Not touching 60, I use sine, huh? Okay. So, 17.32, same. Yeah, same. Now, this 20, I bring to y. But, now I touch 60. This one is 60, right? I touch 60. Right? Fy gonna be 20. Touch. I use cos, right? Not touching, I use sine. Touch, I use cos, right? Cos 60, right? 20 cos 60. So 20 cos 60 calculator, 20 cos 60. How much is this? 10. Yeah, same. Same. I don't care whether teacher you use sine or I use cos or I don't care. As long as you use the way touch and not touching, then okay already. Right? Then you can get the answer exactly the same. But if they give you 30, you better use 30. You don't use your own number 60 here. No. Not encourage you to use. Yeah, it is correct, but no, don't use. I am not encouraging you to use it. Okay. Now, this is the faster way to do it. But anyhow, I need to explain the whole thing for you. Alright. I explain the whole thing for you. So here, this is like, for example, it is 20 Newton. Here, how much? I don't know. This one is 30 degree. This is Fy. So from here, actually it is come from what? Alright. So it is sine 30 is equals to opposite over hypo. Sine is opposite over hypo. 20 come to here. Right? Fy is equals to 20 sine 30. So 20 sine 30, we got it just now. It is 10 Newton. Yeah, that's how we got it. Right? Fx is equals to adjacent over hypo. Alright? So, oh, no. Alright? Cos 30 is equals to adjacent over hypo. This one bring to here. 20 cos 30 is equals to my Fx. So, that's why we got Fx is, now you use my way, you see, how much is Fx? Fx is 20, bring to here, touch, cos 30, right? 20, I bring to here, touch, cos 30. 20, bring to here, not touching, I use sine. That's all. Okay? Now, if you, okay already, now we quickly go for some example, right? Now, example number 22, find the normal reaction, find the acceleration of the object if the frictional force is 2 Newton. Alright, so first of all, you need to label all the forces in first, right? So that is a weight, that is a reaction. Alright, label it. Okay, now here, this one, it is going to move to the left and right only. It is not going to move up and down. Even I pull here, but it is not going to move up, right? So, but this thing, it is in horizontal, it move in horizontal only. It is not going to move up and down. So, the one that go up is equals to the one that go down. Up is equals to down. Right? Meaning this one plus this one is equals to this one. Okay, so I'm going to write into this way. But actually, you can no need to write this. Later, I am not going to write this. Force up is equals to the force down. The force going upward is equals to the force going downward, right? So, the force that going upward is R plus this one. 20, bring to here. Touch 30 or not touching 30? 20, I bring to here. These both are going up. 20, move to here. Do I touch 30? No, right? No, then I use sine. Okay. So, R plus 20 sine 30 is equals to the one that going downward. Downward is W. W is equals to mg. Okay, mg. So I am going to find R is equals to mg. M is 2. G is 9.81. 2 times 9.81 minus 20 sine 30. 20 sine 30. Okay, so in the calculator, so 2 times 9.81 minus 20 sine 30. How much it is? 9.62. Unit is Newton. I repeat one more time because this is the first time that you do this kind of question. Alright. So here, there is a force. You need to know this is R. And then this one is W. So this thing, it is not going up and down. Even you pull here, but it is not going to go up and down. Right? It is moving horizontally. So that is another force, 20 here. 20, I need to bring to here. Total force here and here is equals to here. R plus 20, not touching, I use sine. R plus 20, 20 sine 30 is equals to the weight mg. Okay, the force going up and down, alright. So you solve it, then you will get it. Now the force that going to the right, they said accelerate to the right. So now accelerate to the right mean the force going to the front, it is bigger. So that is an acceleration here. That is an acceleration into this way. Because of you pull here, right? 20, bring to here. This one minus this one. This one is my frictional force. I label it first. This one frictional force. How much? Frictional force is 2 Newton. Okay. Alright. Like usual, frictional force is 2 Newton. Now, the one that pull it to the right, it is 20. Right? 20, sorry. 20, but it is not 20 to the right. It is 20 something to the right. How much it is? Right? 20 touch or not touching? 20 touch or not touching? Okay, you need to know touch or not touching. So, find the acceleration here. F resultant force is equal to MA, right? Okay, resultant force is equal to MA. Resultant force is 20. 20 touch 30 minus the one that moved to the left. Right? 20 cos 30. 20 cos 30 minus 2 is equals to MA. M is 2, A I don't know. Right? So 20 cos 30, 20 cos 30 minus 2 is equals to this, and then divided by 2. My A is 7.66. MS negative 2. Alright. I repeat one more time because of this is the first time. Repeat one more time. Okay. So you got a force pulling here. So this force contribute how much to here? 20 touch 30. 20 touch 30 minus here is equals to your resultant force, which costs you a acceleration. Right? 20 cos 30 minus 2 is equals to MA. My A gone. What happened? Okay. 20 cos 30 minus 2. 20 cos 30 minus 2 is equals to MA. M is 2. A don't know. So find A. Are you okay with this? Now, if you don't use, hey teacher, I don't want to use yours, right? So up to you. What is the way that you want to use? Okay. Now I redo it without using my way. I just tell you it is harder, right? Okay, never mind. Okay, I redo using this one. You don't need to copy. Just listen only, right? Okay, see. This one I cut. Wait, this one cut. How to cut? Cannot. Delete. Okay. So now this kind of question, find the R and find the A. Okay, so you see how I do? Now the one that force that going here, okay, and then that is the force going down. It is called wet mg, and then this one it is a force R, and then this force is the force that going to the right, acceleration. Okay, now this one is 20 Newton. I label it in. This is 30 degree. Okay, now I don't know which one. I try to use a this is not A, this is a force, force X. This is Fy. Okay, now sine theta. Alright, let's say I use sine theta. Sine theta is sine 30 is equal to opposite over hypo mg over 20. Alright, so 20 go up. Mg is equals to 20 sine 30. So what is mg? Mg in this case, because of this one is not going up and down equilibrium, mg is equal to r. R is equal to 20 sine 30. Right. Right. Okay. So what we got is R here. R is mg. It should be minus. Wait. So long not using this way. Mg is going down. R is going up. Right. R. Oh, wait. Let me see. If I draw the triangle, this one, R that is going up. Mg is going down. Yeah, Mg is going down. R is going up. I short of one R. Cannot do it this way. No. Don't use this way to do it. Forget about this. Hey, don't. No. Use my way. Okay. We look at example number 23. One more time. Look at this. Look at this. So here, find the normal reaction. So label all the forces in first. Right. So that is a W. Here going down. That is a R going upward. W. Okay. So now find the normal reaction. So this force, this one, pull to here. So total force go up is equal to the total force going down. Right? Up is equal to down. Right? So up is equal to down. So R plus 20, not touching, I use sine. Right? R plus 20 sine 45 is equal to the one that going down. Is equal to the weight. Weight is equal to mg. M is 2. G is 9.81. Okay, so you can find the R. You bring the 20 sine 30 to here. Alright, so 2 times 9.81. 2 times 9.81 minus 20 sine 45. So I'll get 5.48. Unit Newton. Yeah, number 1. Okay, now this is number 1. Okay. Number 2, find the acceleration. So this thing, when I pull it to the right, I pull it. So this is the force that contribute to the right. 20 touch 45, right? Minus the friction. So it costs you the MA. Okay, so number 2, F is equal to MA. F is equal to MA. F is 20, 20, touch 45. 20 cos 45 minus the frictional force. How much is the friction? Friction is 2 Newton. Is equal to MA. M is 2. A I don't know. I repeat one more time. So 20 touch 45 minus the friction is equal to my net force, resultant force. 20 touch 45 minus the friction is equal to my net force. Net force is equal to MA. Alright, so I can solve this. 20 cos 45 minus 2 divided by 2. 20 cos 45 minus 2 divided by 2. So I got 6.07. Okay. Alright, so this is how we do it. Alright, this one is simple one. So we try to have a look into something that is harder. Alright, so for example, this kind of question. So, let's continue. Okay, now example number 24. So what I need to do is label all the forces in. Draw all the forces in and label it first. So this one is called reaction. This one is called weight. And then don't forget there is a dotted line here. Because of here it is your 30 degree. Here you got a 30 degree in between this angle. Alright, I told you already why. It is same as this angle, always the same. No why, just same. Alright, I told you already. Okay, so number 1, I want to solve this one. Now, first of all, what I need to do is this one and this one always the same. Because of this object, this 2 kg object, it is only can slide down into this way or going up into this way. Cannot go up, only can slide down. Because of you don't pull it. It can only going down into this way. It will not go into this way or this way. Right? Because of that is a reaction. So it won't go in this way and this way. So it only can slide down this way. Okay, so this one is always same as this one. Okay, so how to do this? R is equals to W touch 30 or not touching 30. I don't mean to say this black one. I said the red one. So this W touch the anchor 30 or not touching. So the anchor only see here. Alright, I repeat. The anchor you only see here and here. You don't see here. It is outside. No anchor. Alright, don't see that. Okay, so this W touch 30 or not touching 30? Touch, right? Touch, I use cos. Okay, R is equal to W cos 30. Right, W how much? Mg, right? Mg. M it is 2 kg. G is 9.81. 2 times 9.81 times cos 30. Right? 2 times 9.81 times cos 30. 16.99. 17 lah. Around off. 16.99 no. Follow. Because the answer here is 16.99. Okay. Alright. Okay, number 2. Number 2, they want to find the acceleration of the 2 kg object. Alright, so as I told you, this thing, it is going to slide down, right? So slide down with this acceleration, meaning that this is the force that pulled it down. This is the weight, but this is the we called it as component of the weight down the plane. This one contributes some force to here, right? Okay, W bring to here, touch or not touching, touch 30 or not touching 30, touch 30 or not touching 30, not touching, right? Not touching, and you sign. W sine 30 minus the friction, smooth plane, no friction, W sine 30, F is equal to MA, W sine 30 minus the friction. Frictional force is 0. Is equal to MA. M is 2. A, I don't know. W sine 30, right? We know W how much? Mg. 2 times 9.81. Okay, so 2 times 9.81, 2 times 9.81 times sine 30 equal, divided by 2. I got 4.905. Unit is ms negative 2. Okay, very, very easy. Very, very easy. If you follow the method that I taught you, then it will be easy. Of course, teacher, I want to label a force, the A accelerate to here. Can or not? Can. Go ahead. But this one is not the force. You need to know this is not the force. Only this one and this one is compulsory to label. Right? If you don't label, you cannot do. So this acceleration is tell you, oh, it is accelerating downward. Normally, we don't label it lah. Right? Okay. Question? Should be okay, right? So the next question. So label all the forces in. So that is a weight. That is a reaction. Reaction always 90 degrees to the surface. Remember. That reaction here, R, is always 90 degrees to the surface. Okay? And then here it is your angle. This angle is 30 degrees, as you know. So I label other force. This one is R. This one is, if you want to label is mg, okay. Because W is equal to mg. No problem. Right? So find the acceleration if the frictional force is 2 Newton. So because of this object, it is going to slide down. Why it is sliding down? Because of you got weight. The weight you put there, then this weight, it is going to pull it down this way. So when you pull it down this way, then there is a reaction here. This one is called, not reaction. This one is called frictional force. So I label all the direction. So the frictional force is here. Frictional force, mu is 2 Newton. Okay. Now, we are going to start to do. Alright. So this one is equal to this one. Right? You tell me, teacher, this one is going down this way. Oh, this one is going down this way. Yeah, doesn't matter. Because of it is not going up this way or this way. Right? This one is like left and right. This one is like up and down. So even you tell me, teacher, this one is down. We take this one as left and right. Okay? So it is not going to this direction. So R is equal to W. W touch or not touching? R is equal to here. R is here. R is here. W touch or not touching? Touch or not touching? Touch or not touching? Touching, right? Touching, we use cos. R is equal to W cos 30. R is equal to W. W is mg. M is 2 kg. G is 9.81. Cos 30. I use time better. This one looks so ugly. Okay. How much is this already? I forgot. Same as just now, right? Oh, they don't ask me the error, but never mind. I just do it. I just did it. I don't know. Alright, but never mind. They ask us. They don't ask us to do. Okay, 16.99. Yeah. Like what we have done just now. Okay. This one they don't ask us to do. I better cancel it. I just tell you, you need to do this. Right? If they ask you. Now what do they ask us is find the acceleration. So what is the acceleration here? So because of this weight, it is pulling down here. W, touch the T or not touching the T? Touch the T or not touching the T? Here, W, touch the T or not touching the T? Right, 30 is here, 30 is here. W, touch the T or not touching the T? Not touching, you sign, right? If you don't know what is touching or not touching, all right, you ask me again. I will explain to you until you understand. If not, later you will be like, you don't know what to do already, right? W is W. F is equal to MA. W sine 30 minus the friction minus 2 is equal to MA. M is 2, A I don't know. Right? So W is mg, right? M is 2, G is 9.81. 2 times 9.81 times sine 30 minus 2 is equal to 2A. So we can find the A. Okay, divided by 2, 3.095. 3.095. Unit is ms negative 2. Eh? Yeah, correct. Eh? Why cannot? Eh? Whatever lah. Okay. Alright. Are you okay with this? Okay, I hope you are okay with this. Okay. So here, this question. Now, label all the forces in. That is a weight. That is a reaction. 90 degree. And then this is a normal line. 90 degree. Okay. 90 degree. Yeah. So this angle is same as this angle, 45. So now you see here, there is a friction. Because of this thing is going to slide down. So here it is a friction. How much is friction? 5. That's it. Okay. Alright. So I label everything in already. This is R. This is W. Okay. Now, here, this force is equals to this force. Up is equals to down. Right? This one is W. Touch or not touching 45. Right? You try to write down the equation. R is equals to this one. Okay, so I hope you already write it on your own. R is equals to W cos 45, right? W is mg, R is equals to mg, m is 5 kg. 5 times 9.81 times cos 45. 5 times 9.81 times cos 45. So I'll get 34.68. Unit Newton. Okay, number 2. Number 2. So, here. This one, find the acceleration mean this one is going to slide down, right? So, this force pull to here minus this force is my net force, is my resultant force going downward. Okay? This force bring to here, touch or not touching. I mean this angle, touch or not touching this angle. Not touching, I use sine. Right? Not touching, I use sine. Okay. W sine 30 my I didn't write F is equal to MA. If you get used to it, you don't need to write. Right? Minus the friction. If you want to write, then go ahead. Right? F is equal to MA. Right? So MA. M is 5. A I don't know. Right? W is I need to write W is 5 times 9.81 times sine 30 minus 5 is equals to 5A. 5 times 9.81 times sine 30 minus 5. And then divided by 5. So I get 3.905. Eh? Oh, not 30. 45. What am I doing? Ayah. Sorry, Okay. So repress. 5 times 9.81 dreaming times sine 45 minus 5 equal divided by 5 equal 5.93 5.94 5.94 ms minus 2. Okay. So basically, this is a few example that I teach you. Now, if in the future you got a box here, you got a box here. Your question in SPM or in STPM, if university also can do. Right here, you got one force, you got two force, you got a frictional force. Right, this is 30 degree. This is 40 degree. This is 20 Newton. This is 5 Newton. This is mu is 2 Newton. Right, this is 2 kg. So you can do this. 20 cos 30. 20 cos 30 minus 5 cos 40. And then minus mu is equals to 2a. Yeah. Even more than one force, 2 force, 3 force, 5 forces, all can do. So you can do it. You don't need to draw triangle. Right? No need to draw triangle. Okay? This is how we do it. Okay? Any question before I continue? Alright. So if no, then we try to 1.3. So I let you try to do some question first. I let you rest for a little while. Right? Before we go to 1.3 equilibrium. Let me see, can do any question or not. If not, I tell do this one, then we cannot. We need to take longer time. This one, I think need quite long time to do. Okay, I let you try to do one or two question lah. Never mind. You try to do. Let me see. Okay. Okay. Page 64. Wait let me see. Some you can do, some you cannot do yet. Page 64. You do one question only. Page 64. Here, this question. Wait page 64. You try to do this question only. Alright? One question. Be right back in after 5 to 10 minutes. We continue again. If you got question, PM me or ask in the chat box. Alright? I'll see you later. Okay, I'm back. All right. Mm. We try to do this question. All right. How to do this question? 120 touch. We use cos. Right. Frictional force. Right. So F is equal to MA. 120 cos 35. Touch, touch we use cos, cos 35 minus 20 is equals to MA. M is 7. So A is 120 cos 35 minus 20 is equals to divided by 7 equal to 11.19. 11.19. Answer is C. Class 10 course physics 2. Hi, can you teach the class 10 CBSE? I don't get it. What is CBSE? What is class 10? What does that mean? What does that mean? Hi, can you teach the class 10 CBSE? I don't get it. Okay, so we continue from here. This is SPM. SPM. If you said IGESE, IGC, IG, what was that called? IG, wait, IG, IGCSE, IGCSE. I don't teach that. If you got question, you can ask. Related question, you can ask. I try to see whether I can answer or not. Because I don't teach that syllabus. Okay. So we quickly move to equilibrium. Right? What is equilibrium? So equilibrium resultant force is 0. Mean this object is not moving, or if moving, equilibrium, if moving, it will move with constant velocity. So normally this kind of question, it is not moving one. Mean the force to the left, when equilibrium, the force to the left is equals to the force to the right. The force that going upwards is equals to the force that going downward. Okay. Now, example number 27, same thing, all right? Same thing. So, now, first of all, we label all the forces in first, right? First, this one is the tension of the rod, right? Tension. This one is the tension of the rod. So, this tension and this tension only the same when their angle it is the same, right? So this one, if not the same, I'll name it as T1 and T2. Right? One is T1, T2. Up to you. Which one is T1? Which one is T2? And then they'll ask us, find the tension of the rod, each rod, right? T1 and T2. And then draw the triangle of forces. They want triangle. Alright? So this is what they want. Later we are going to draw it. Now, first of all, Okay, now the force that go to the left is right. Okay, the force going to the left is T1. T1 is equals to the force going to the right. The force that going to the right is this one, T2. T2, and then touch this angle. This angle. So I haven't labeled in what is this angle. So what is this angle? This angle is ZZZ. This one is 30. Alright, we are going to put it in 30 first. Right. T1 is equal to T2. T1 is equal to T2. Touch 30. Touch 30. I use cos. T2 cos 30. So we cannot continue from here because of I got two unknown here. Alright, so I leave it at the first equation here. Now I want to write the second equation. The second equation is this force is going to the left. It is not contributing to the up and down. So no need to resolute this one. If you resolute it, it will give you a 0. Okay? So T2, I bring to here. Touch 30 or not touching 30? Here. Touch 30 or not touching 30? Is equal to the force going downward. Force going downward, I also haven't labeled yet. This one, W. Okay, I repeat. T2, touch or not touching 30. Right, see properly. This is 30. This is 30. Touch or not touching 30. T2, not touching 30. Sign is equal to this one. Right, the force going up is down. Okay, so the second equation is T2 sine 30. T2 sine 30, not touching 30, right? Is equals to the force that going downward, mg, right? So this is my second equation. Okay, so I can solve this, right? T2 sine 30 is equals to m. M is 4, G is 9.81. 4 times 9.81. Right, so I can find T2. 4 times 9.81 divided by sine 30. So this is my answer, 78.48. T2 is 78.48. Unit is Newton. Force is in Newton. 78 and 48. 78.48. So I want to find T1. So it is T2 cos 30. So T2 here, T2 time cos 30. Time. Answer just now. Time cos 30. So 67.97. 67.97. T1 unit is Newton. Right? So of course you can write something like from one T1 is equal to T2 this one cos 30. If you want to continue to write it, it is okay here, right? So because they asked us to find this one only. Question? Now we are going to draw the triangle. Triangle, you got two answers here. Alright. So now first one, this one is equilibrium. It is totally different from resultant force that we have done previously. Okay, so here it is. So I always like to draw the W first, right? This is W, right? W. This is W, right? And then this is T2, and then this is T1. Right, label all the forces in. I said got two answers. Alright, I'll do another answer later. Right. One is T1. Alright, the direction, make sure it is correct. T1. And then this one is W going down. W going down. And then this is T2. This is T2. And then make sure the angle it is correct. This is T, this is T2, this is T2. Here it is 30. Here it is 30. Zigzag zig mean here it is 30. So label the angle. Right, this one is 30 degree. That's all. Finish. Right, this is the answer. Right, this is the answer. Now, they ask you to draw. So I got another way. I said got two way to draw, right? Okay. If you don't draw this way, right? W first, okay. And then you don't draw T2, and then you draw T1 first. T1. T1. This is W. And then this is T2. Right, this is T2. Right, this is T2. This is T1. This is T1. The direction, make sure it's all correct. W going down. If you put this one into here, you find it is a parallelogram. T2, T2, T1, T1, T1. And then going down, wait. Right? So, this is the same thing. Right? This one, you can extend, become a parallelogram. But they mention right now, it is a triangle. So, you have to do it with triangle. And then, the second thing is, make sure you follow, which is, when they said, this one is in equilibrium, mean the T1, the arrow going here, it will go in one round. It will circulate in one round. You see? T1, TW, and then T1. So this one mean equilibrium. They can go back to the original point. So this is parallel. This is equilibrium. Now, of course, Jagu, I know this one, but I go back for a little while. So we look at the resultant force. All right. Okay. Now, teacher, the previous one you taught us, it is not like that. Oh, okay. You see, parallelogram. Okay. So T1, T2, and then it cannot go back. Yeah. You pull here, I pull here. Right, you pull here, I pull here. The force is from here to here. This is not equilibrium. This one is going to accelerate. It is not equilibrium. So that's why this one is two arrows here. Alright, this one is called resultant force. You start from here, move to here, move to here. It is from here to here. It is not going back. If going back to the original point, that one is called equilibrium. Right, make sure you get it. Okay, the previous one, this one is the previous one, resultant force. Okay, now I said you got another way to draw. Up to you which one. Now, hey, teacher, my teacher taught us, it is this way. Draw this one first. Yeah, some question they'll ask you, draw the triangle first. And then hence, use the triangle to do it. Which is, I don't like to do it that way. I don't teach that way because of I think it is so slow. Right? But anyhow, if they taught you this, ask you this way, you have to use a triangle to do it. So now I try to use triangle to do it. W is equals to mg, right? Sine 30 is equals to opposite over hypo. W over T2. I repeat, sine 30 is opposite over hypo. Right? Opposite is weight. Sine 30 is equal to mg 4 times 9.81 divided by T2. Right? This one go up, this one go down. T2 is equal to 4 times 9.81 divided by sine 30. T2 sine 30. T2 times here. T2 sine 30 is equal to 4 times 9.81. Yeah, same thing. Right? T2 is 4 times 9.81. 4 times 9.81 divided by sine 30. Yeah, exactly the same. 78.48. Now I use cos. Cos 30 is equal to adjacent over hypo. Adjacent over hypo. Hypo is here. Adjacent T1. Hypo T2. Right? T2 I know it. Right? Cos 30 is equal to T1 over 78.48. 78.48. This one go up. Right? I press in the calculator. Cos 30 times 78.48. You will get back to the same thing. 67.97. Yeah, exactly the same. Right? But I personally don't like to use triangle to do it. Right? If they ask you triangle first, you have to use this way. Sine and cos. Are you okay with here? Okay, I hope you're okay. Now we move to the next question. Right, this kind of question. Find the triangle, the tension of each rope. Draw the force triangle of forces. Okay. Now, first of all, we got a T1 and T2, and then this is W. And this angle, it is exactly the same. Do you see from here? This angle is 30. Zigzag. This angle is 30. This angle is 30. And the angle 30, 30, both angle, it is the same. Mean the T, it is the same. So you can just name it as T only. No need T1, T2. If you want T2, T1, T2 also okay. But you know it is T already. Just T. Alright, so this is our W. W. Now, okay. This one, the force pulling here is, I resonate to here. This force pull it to here, I resonate it to here. Left is equal to right. So this one meaningless. Why? If I write it, I will get T cos 30. Touch 30, wait, T touch 30. T touch 30 is equal to T touch 30. T cos 30 is equal to T cos 30. Cos 30 cancel. T is equal to T, no use. Right? Left, right, no use. Because of the force, it is the same. Left and right, it is the same. And then both force is T1 and T. So, useless. So, how about if I put it upward, the force that going upward, the force, total force that going upward, this force is T. I bring to here, touch this 30 or not, touch this 30 or not, touch 30 or not. No, right? Not touching, I use sine. This one, I also not touching 30, I use sine. Alright. So, T sine 30, T sine 30 plus T sine 30 is equals to the force that going downward. Alright, I repeat. Force that going upward and the force that going upward, total force that going upward is equals to force that going downward. Because of this is T sine 30 and T sine 30, you can write it as 2T sine 30. 2T sine 30 is equals to my mg. Right? 2T sine 30 is equals to m. M is 5. G is 9.81. So I can find the T, right? So 5 times 9.81. 5 times 0.81 divided by 2 divided by sine 30. 49.05 unit Newton. So the force that I told you, T and T both are the same. So both T are 49.05. That's all. Okay. Now we are going to draw the triangle. So I told you triangle, we got two answers, right? But never mind, you just leave one enough, right? T1, T, right? I normally like to do W lah, right? W, E. W, right? W first, and then T, and then T. Finish. Alright, this is W. This is T. This is T. Alright, so now I try to see this way, and then go back to the original point. Go in one round. Okay, no problem. Yeah, boleh. Listen. Okay. Okay, and the angle. Alright, the angle. T to the horizontal. T to the horizontal here is 30. This one is 30, zigzag, Z. Here it is 30. Here is 30, here it is 30. So total here it is 60 degree. Total here it is 60 degree, right? 60 degree. Yeah. If you want, here is also 60, 60. Right? 60, 60, 60. All 60. Right? I just label one enough. If you want label all, then all. This one's 30, this one 90, this one 60. I hope you can understand it. This is just normal mathematics. Now, like if you draw it this way, I said another answer is W going down. Right, teacher, I want T2, T, this T first. Okay, this T first. Okay. T and then this T. T and T. This is 60. Right, 60 degree. You bring this whole thing to here, you form a parallelogram. Alright. This one will be hard. Alright, this kind of question will be hard. Harder lah. Not hard lah. Harder. Slightly harder. Okay. So we look at example number 29. This is Z 20 here. This one is 40 here. I put in the angle first. Now these two angles it is not the same, so the tension will be different. So I name it as T1 and T2. Up to you which one is T1, which one is T2. As long as the answer it is same, then okay already. T1. T2. Okay. So there is another force that going downward. It is called weight. W. Okay. Now, without drawing a triangle, right? So I want you to try to write an equation, right? Left is equals to the right. Left is equals to the right. You try to write it. I help you a little bit. T1 what is equals to T2 what? I repeat. T1 what is equals to T2 what? Write that equation. I hope you have done it. Not very hard equation. T1 touch or not touching, right here. Touch the 20 or not touching 30. Touch 20, right? Touch will use cos 20. is equals to T2. This one I bring to here. Touch or not touching 40? I said don't use this one. Look at this angle or this angle. Not this angle. I mean, teacher, what angle again? Okay, the angle is like here. This angle or this angle. Not this one lah. Yeah, this one is this one. Right. You have to know. So, T2, touch 40, cos 40. Okay. Okay, so two unknown cannot do, right? So I'll leave it as T1. T1 is equals to T2. This one. This cos 20 going down, divide. Right? Divide. Divide by cos 20. So I leave this equation as 1. I leave it as 1. Alright, done. I want you to try to write another equation that total force that going upward and the force going upward, total force that going upward is equal to the total force that going downward because of equilibrium. I repeat one more time. The force that going upward plus the force that going upward is equal to the force that going downward. Write it. You're trying to write it already. So, T1 I bring this T1 I bring to here. Touch 20 or not touching? 20 is here. This 20 is here. Touch or not touching? Not touching, I use sign. Okay, T1 sign. Sign still sign 20. Still sign 20. Alright. Plus the force that going upward here. This force T2 not touching 40. T2 sine 40 is equals to the weight that going downward. Right? The force that going downward is mg, right? Okay, mg, weight. Okay, so m I know, T1 I don't know, T2 I don't know. That is two equation. Never mind. Is equal to mg. M is 6 times 9.81. Right? This one is second equation. Okay. Now what I want to do is I want to substitute this T1 into here. The whole thing into here. So that I got one unknown only. Sub 1 into 2. Right? What do I have? What I have? Okay. T1. What is T1? T1 is T2 cos 40 divided cos 20. T2 cos 40 divided by cos 20. This one is T1 time sine 20 plus this whole thing in T2 sine 40 is equals to 9.81. 6 times 9.81. Alright. Okay. I repeat one more time. T1. What is T1? T1 is this one. Alright, I'm gonna put into here. Which is this one. This one. times sine 20, times sine 20 plus this one is equal to this one, right? Same thing. I just substitute into it. So after I substitute, I just press the answer, right? Because of you can take it out the T2 and T2, you take it out this one T2. So this one is something. This one over this one times this one plus this one, right? So to get the answer directly, I'll press the here. I press this one. 6 times 9.81. 6. No. I press this one first. If you press this one, it's kind of hard for you to get here. Right? Cos 40 divided by cos 20 times sine 20. Right? Plus sine 40. Right? Equal. This one is here. T2 I take out. Right? So I want to divide by this one. So I press inverse. Then it go down already. Inverse means divide already. Times 6 times 9.81. Then it will be my answer. 63.86. 63.87. So I got my T2. T2 will be equal to 63 point. I forgot. At 7. Unit Newton. So I found this one, then I substitute this one back into here, right? How much is T1? When I bring this one up a bit. Okay, how much is T1? T1 is T2, T2. T2. T2 is this one, time cos 40 time cos 40 divided by cos 20. So T1 is 52.06. Unit is Newton. Okay, finish. T1, T2. T1, T2. Up to you. Which one T1, which one T2, it is okay. This kind of question will kind of more complicated because of it consists of two unknown. Right? For this kind of question, it is easy. This kind of question, it is easy. Okay. I hope you are okay. They ask us to draw a triangle. So we draw a triangle here. Wait first. Always wait first. For me lah. And then T2 and then T1. Finish. T2, T1. Right. So here, label the direction. Weight is going down. Right. This is the weight. This is T1. This is T2. And then Z here is 40. Meaning that T2 to horizontal is 40. T2 to horizontal here is 40. Z here it is 40. And then here is 20. Right. T1 to horizontal. T1 to horizontal is 20. Here is 20. So 20 plus 40, it is 60 here. This angle here, it is 60. This angle is 60. Okay. Is that okay for you? If you want to use this one to do, you need to use sine rule and cos rule. So complicated. I don't want to do. You can do it. You can use this triangle to calculate. Right? You can use this angle to calculate. Right? Which is what is this angle? This is 20, right? 90 minus 20 here, it is 70. This is 40, right? 40 you can label it lah if you want. This one is 50. Right. 70 and 50. Here's 70. I put it in, never mind. 70 degree. And here gonna be 50 degree. Okay. If like that, it is not that hard. Can use sine rule. Alright. W. Okay. I try. T1. T1 over sine 50 is equal to T2 W over sine 60. Very easy leh. W is 6 times 9.81. 6 times 9.81 divided by sine 60 times sine 50. Yeah. Not hard leh. Oh, I thought it is hard. But never mind. 6 times 9.81 divided by sine 60 times sine 50. That's all. 52.06. Yeah, not hard leh. T2, you want to find T2 okay, let's say you want to find T2, right? This one over this one, this one over this one, yeah. T2 over sine 70. T2 over sine 70 is W, right? W over sine 60. Not hard leh. W is 6.9.81. 6 times 9.81 divided by sine 60 times sine 70. 70. Wait. W is 6 times 9.81 divided by sine 60 times sine 70. 63.86. Add 7. Yeah, same. Can. Both are okay. If you use triangle, it is not that hard also. You use sine rule. Some question you cannot get the angle, then you might need to use cos rule. If cos rule, it will be more complicated lah. Alright. Okay, I have solved both equations. So we try to do this example. This example, it is easy. Why? Because the angle, it is the same. So I put in all the angle first, right? W, and then T1 and T2. T1 and T2, it is the same. We called it as T because the angle, it is the same. Okay. Find the tension of each drop if the mass is 7.5 kg. Alright. The force to the up here, left is equal to the right. Because of this one, left is equal to the right. So you get back to the same thing. So no need. So just put up is equal to down. The force that going upward is equal to the force going downward. Okay. T, touch or not touching? T, touch or not touching? Not touching. Not touching 40, we use sine. We got 2 times of sine. 2t sine 40 is equal to the weight. Why 2t? Because of 2 times. 1 time t sine 40. This one also t sine 40. We got 2 times of t sine 40. Is equal to the weight. Weight is W. 2t sine 40 is equal to W. W is mg. Mg 7.5 times 9.81. 7.5 kg is given. Alright, so we can find the t. So 7.5 times 9.81 divided by 2 divided by sine 40. 5723. Unit Newton. That's all. Seems like not very hard, right? They didn't ask us to draw, I didn't draw. Right? If they ask us to draw the triangle, go ahead. Alright. We try to do some question together. Okay. MRSM 2025 diagram 18 shows a signboard hanging on the road. Selamat datang ke Magma Physics. What is the triangle force represented this situation? So this one is T. No. Here, this is T1. This is T1. This is T2. T1, yes. T2, yes. W, going down. W. W wrong. T1, yes, T1. T2, yes, T2. W, W going down. W going down. T2, 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 W. W going down. T1, yeah, T1. T2, yeah, T2. So you just do it this way. You no need to draw on your own. If you draw it on your own, you got possibility cannot get it. Alright, I try. So teacher, you said draw W first. Okay. Mana tahu you draw T2 first. T2 and then lastly T1. Yeah. T2 this way, yeah. T1 this way, yes, T1 this way. Okay. Alright. So T1 teacher don't have. Because I told you there is 2 answers for this question. So you just follow T1. Oh, T1. T2. Oh, T2. Mana tahu is this triangle, not this triangle. Right? But both are okay, actually. Answer is D. So you just follow the direction of this one, then okay already. Okay. There is a truck with the mass 2 kg with the inclined plane. Alright. So label all the force in. Right. The forces in. So this is 30 degree. Put it in. $30. Okay. So all the forces in. This is called reaction. This is called weight already. Is there any friction? No. They didn't say. They don't say any friction. So this one is called R. So what do they want? Calculate a component of the weight which is parallel to the plane. Meaning that they want the component of the weight here parallel to the FWX here. The weight in this way. The weight come into this way. So this one W, touch or not touching? W, I bring to here, touch or not touching? Not touching, I use sign. Okay. So WX, the name is WX, is equals to W sine 30. W is weight. Weight is 2 times 9.81. Okay. So 2 times 9.81 times sine 30. I'll get 9.81. Unit Newton. 9.81. Answer is A. I repeat one more time. Calculate the component of the weight here, WX, which is parallel to the plane here. So they want this one bring to here? How much? So this one is called Wx. This one is called Wy. Why? Why? Right? They didn't ask us about the Wy. Okay. What is resolution of force? Resolution of force is I got a force. I got a force here. I am going to bring to here and here. This is what we have. The process of resolving a single force into its component. Yeah, quite correct. Alright, component, what component? X and Y. Alright. The process of resolving multiple force into one single force. No, that one is multiple to one is resultant force. Alright. So combining single force into not combining. It is resolving a single force into the X and Y. So answer is A. Okay. What is the force of F? So diagram shows a box 5 kg being pulled by the force in the rough surface. The frictional force is 6 they gave you. Right? The acceleration is this one. Okay. Now F you pull to here, so it will cause the acceleration into this way, right? Yeah. So this force you come to here minus this is your net force. Is your resultant force. F is equal to ma. I don't want to do. Right? I repeat one more time, you try to do. F what? And then here, friction pull you, don't let you go forward. It's equals to your resultant force. F what? I just draw an error for you. You write the equation. Alright, so done. Okay, so F touch 43 cos 43. F cos 43 minus the 6 is equal to MA. M 5 kg. A acceleration they gave you 2.42. Okay. 5 times 2.42 plus 6 equal, right? And then divided by cos 43. Divided by cos 43. So 24.74. Newton. Right? 24.75 around off. Okay. So answer is A. Can you do it? Yeah. You see, if you use my way, it will be very, very easy to do. Right? 1 step, 2 step, easy. If you draw a triangle right now, how? This one, very, very hard for you to do Because of got this one, got two forces. Okay. No, I don't like to use triangle, that's why. Right. This one just now I use a triangle cannot. Equilibrium can. This one because of two forces. Right. Triangle. Okay, now this one got one student PM me about this question. Alright, teacher, how to do this kind of question. Now, diagram 8 shows a method of determining the resultant force, not equilibrium, resultant. Got one force resultant. So you put here, right, by the parallelogram method, which one is represent the resultant force? So here you put here, I put here. Where will it go? You pull here. You try to think. I pull here. So you draw a parallel. You draw another parallel. Right? So this one is in between. It is called your resultant force. OB. OB is your resultant force. Like what I told you before, I purposely put it in here. Here. Like what I told you before. Here, you got one force here. You got one force here. I got one force here. Where will it go? So this is your parallelogram method. So you will get the resultant force in between, like the video that I showed you previously. Okay. Okay. Like this. Like you pull here, I pull here. So it will go in between, resultant force. This is called resultant force. If equilibrium, then you go back to the original point. I told you. Okay. Next. Okay, now this one equilibrium. Equilibrium means it will go back into the original point. So here, you pull here, I pull here. Then this one is your resultant force. No. Okay. You pull here, I pull here, you pull here. Right. This one will go for the equilibrium. Yes. Why? Okay. Because of you pull 3, you pull 4. So this is your parallelogram, right? So you pull into this way. So 5. Here 5. So this one will go for a equilibrium. Right? Meaning that you put 3 and 4, it will give you a resultant force of 5 into this way. In opposite 5 will cause it not moving. So answer is C. Now, how about if I want to draw, right? Never mind. Right? You see? 3 and then 4 and then 5. Right? 5 5 3 3 4. So you see, it go back to the original point. Right? Teacher, this one also go back to the original point. 5 and then 3 and then 4. But not logic. 5 and 3, Pythagoras will not give you 4. This is why we cannot get it. Right? Answer is C. Do you get it? Okay. Diagram 3 shows a worker pushing a trolley containing a few boxes with the force F. Okay, this is a force. Which of the force it is correct in showing the horizontal force component Fx and the vertical force component Fy? Alright, so now this force, if you resolute it, it will go to here and here. Right? Fx and Fy. Right? Fx, correct. Fx, left, right? This is going to the right. Okay? Fx, this one is wrong. This two is correct. And then Fy is going to down. Fy is going down. Right? So answer will be C. Right? Fx, Fx, Fy. then Fy. This force, when I resolute it, it will go into two direction. Answer is C. Okay. So which equation is correct? Okay. Now, this kind of question, here. The force go to the left, F, is T. Touch or not touch? You have to label this theta. This theta is here. This theta is at here. This one, touch or not touch? Left is F, right is T cos, right? So the equation that you should get is, the equation that you might get is F is equals to T cos theta. F is equal to T cos theta. F is T cos theta, yeah? In BM. Okay, one equation already. Now, the one that going upward, T. This one is theta. T sin theta is equal to W. T cos theta is W. This one out. Number 3 is correct. Number 3 is correct. Number 3 is correct. Number 3, number 3, number 3. 1, 3 or 2, 3. The answer is 1, 3. Why 1, 3? This one I told you it is not good. Why? Now, T vector plus F vector plus W vector is equal to 0. 0 means equilibrium. Mean this thing is not moving. Meaning that this is vector. Meaning that T plus F plus W is equilibrium 0. So answer is 1 and 3. They should write the symbol at the top here lah, but they didn't. Now, Ws is a component weight of it is component of weight parallel to the inclined plane. F1 is the frictional force of the boy. F1 is frictional force. Right? This is W, this is R, and 30 degree. This is Fx. Why does the boy sliding down with uniform velocity? Why sliding down with uniform velocity? Uniform velocity mean equilibrium, mean up and down it is the same. Right? Wx is equal to F. The frictional force is greater. If greater, then it cannot slide down. The frictional force is less than, mean it will accelerate. See, the frictional force is equal to the weight parallel to the inclined plane. The frictional force, what am I doing? The frictional force, they said the frictional force is equal to weight. Okay, weight parallel to the inclined plane. Yes, so that it will go in parallel uniform velocity. So answer is C. Okay, next. This one we have done it just now. Okay, one more. So, which of the following diagram produce the highest acceleration? Okay. Now, you want to accelerate to here, right? Okay. So, this one I don't know. This one I don't know. So, I put in a number. If not, you cannot calculate. Right? I put in a number. Let's say each string will give you 100. 100 bring to here. 100 bring to here. So, it is 2 times of 2 times 100 cos here cos 10 here cos 10 cos 10 2 times. This is 100 cos 10. This is 100 cos 10. 100 cos 10 times 2, right? So how much it is? We calculate. 100 cos 10 times 2. 196. So equal to 196. Here it is 100 cos 20 plus 100 cos 20, right? 100 cos 20 and then I type 2 187. You're getting lesser. This one 196, this one 187. So this one even smaller, this one even smaller. Why? Okay. I don't want to use the shift. Alright. You see, I got a board here. No, I got a box here. Right? No, I got a box here. You pull here, I pull here. So which one will go faster to the front? You try to imagine. You pull here, I pull here. The anchor very small. You pull here, these two forces is like contribute to the front here. Contribute to the front a lot. This one is not really contribute to the front. It contribute more to the side here. A little bit contribute to the front. So this one is not going to go fast. This one will accelerate faster. Right? Come back to this question. Come back to this question. You see, this 2020, very small anchor. So you pull to the front, contribute to the front a lot. This one, anchor big, so it will go to the side more. This one even more. To the side even more. So answer is this one, A. Alright. This is your homework. Let me see. Paper 2 is your homework. Yeah. A lot of. Wow. What to do? A lot. Ooh. I told you it is totally a lot. You try lah. Wow. Wow. Really a lot. Until 1:30, I cannot do all. I tell you, you do. I just pick up some to do. You try to pick up some to do lah. I mean, until page 130. About 100 pages. No. 70 pages. You try to do some lah. Alright, you do some from the page 65. 66 until page 130. All is this accumulated question. That is a lot of question about this one. Until 130. You see my question a lot or not? Yeah, a lot. Cannot do all lah. Do all, not you. I also fan. I also pengsan. I will discuss some. I think that is important lah. So many. What to do? I'll pick up some to do lah. You try to you try. I don't force you to do all. You try to do some. If you can finish. You can do. Then you pass up. You have to show me the page. If not, it's very hard for me to find. Like for example, what kind of question it is important? For example, I simply take page 89. Page 89. You see now the diagram shows how flies is cleaning the floor. What is the force? Forward force. So this is the forward force. Forward force. Right. So forward force is F forward. This is downward. Forward force. F touch or not touching. Touch or not touching. Right? F sine theta. F sine theta. F sine theta. F sine theta. Don't have. Right? Don't have then. What is this angle? Then what is this angle? You have to do a bit no? This is 90, right? This is theta, right? So this is 90 minus theta. So F I bring to here. I want forward force, right? Touch 90 minus theta. Cos 90 minus theta. Answer is C. See? You have to, like, sometime, this is K-part question. You have to, like, you have to play around on your own. If not, you cannot get it. A lot, I tell you, a lot. Really a lot of question. But if you can do it very, very fast, very, very easy. Now, how about the structural question? Structural question and essay question, it is kind of less, but it still can come out. This is a question that I want you to do. Like this kind of question, especially this kind of question. Page 110. This is important. 110 until this kind of question. Very, very important. This one still okay. Page 110. From page 110. My homework were given from page 110 until 130. Homework page 110 until 130. Structural question. Other objective you try to do. If you pass up, then I'll mark for you also. Now, this is our last free tuition from starting from next week. So you need to click my link. I send my link. You have to click the link to join the tuition. If you don't have the link, then you cannot join my tuition. If you are interested to join, right? For those who haven't joined, if you are interested to join, so this is this is the link, right? You fill in the form. This is for SPM1. I only teach SPM. If you say you want to have what IG or CBSE or whatever, I don't have it. Sorry, this is for SPM Form 4 and Form 5. Right, click the form to join. So I am going to stop here. I'll see you next week. Bye bye.